In this video, I'd like to work through an example, and in this series of videos, work through a number of examples so you can see the simplification process. So let's begin with our algebraic statement. This is what it looks like. It's quite complicated. And we have a knot here, and we have a knot here, and a bracket here. Typically, that bracket there corresponds to that bracket. So we have quite a complex algebraic statement, and what we really need to do is simplify it. So how do you go about it? Well, the very first step I would suggest is you remove these brackets, but you do them using the BODMAS sequence. What you need to do is start with this one here, resolve this one here, and then multiply all through by C. Now, once you get it into that stage, you get it into form which is easier to manipulate and spot the patterns to apply further rules. So let's first of all try to simplify it. So we start with this bracket in here. We multiply this block by each of these terms one at a time. So let's do that. Let's use a different color so you can see this. So we've got A, B, not B, C. That's this first one, plus A, not B, B, D, which is this bit multiplied by that bit. Put our big bracket back on, C, and then we add in A, and not B. Okay, so that's the first thing. We have multiplied out this bracket, inner bracket here. We now have an outer bracket, but before we do the outer bracket, it's worth spotting a pattern straight away. The very first pattern is if a gate is multiplied by its knot, right? So the rule is if there's a gate and it's multiplied by its knot, that according to the rule, that actually cancels to 0, which means that this term here can be cancelled out. So straight away, we've ended up with a very, very quick simplification. So we'll have the C still, the bracket, A, B, not B, C. This middle term has gone, and we add A, and not B. Okay, so that's where we've got to. Now, when we get to this particular point, what we're trying to look at now are patterns to proceed. Actually, before we go any further, before we do that, we've still got a bracket to get rid of. So let's do that. Let's open up that bracket. So it's C, let's write it differently. Bear with me a second. Let's get rid of that C there, and let's try that again. Right, so we've got A, B, not B, C, C, which is this, right, in that term, plus not A, not B, C. Straight away, we can see another rule here. C, C multiplied together always collapses to one of them. And that comes from this rule, that if x is multiplied by x, it gives you x. So this nicely simplifies, which we will do on the next page. The last statement simplifies to A, B, C, which is the CC collapsed into one, not A, not B, and C. Now, how do we approach this when we get it to this? This is what we call the SOP form, the sum of products form. It's a very important stage when you are going through Boolean algebra. It's at this point that we could go off and use Carnot maps, or we carry on with Boolean algebra. So these initial steps that we talked about are the initial steps for both Carnot maps, badly written, and Boolean algebra. So in this version of the video, we've proceeded the same steps. We're not interested in the Boolean algebra, we are interested in Carnot maps. So what we're going to do is take this statement here and convert it using Carnot maps. So the first thing we need to do is let's write our SOP form, sum of product form. B, not C. Okay. In order to convert this into a KMap, we have to first of all identify the number of inputs, and we have 3. When we have 3, we combine one pair we put down the column, and the second one we put, the third item rather, we put across here. So these combinations are 2, 3, 4, 0, 0, 0, 1, 1, 1, and 1, 0. Please note that the sequence in which I've written this out, these steps can only differ by 1 bit. Okay, that's quite crucial in how you construct it. So what we do is we take each of these terms and set it to 0. So it's A, not B, C equal to 1. That's what we're first going to try to map onto this structure. Okay, so A, we need A to be true. So let's take it a piece at a time. I'll use a different color. I need A to be true. So these are the two rows where A is true. We also need C to be true. So this is the column. So it looks like it's going to be possibly here. But here's the third combination, not B. So B needs to be false. That's where B is false. Therefore, that is the only place that we put the combination for that first item. Let's get to our second one. A, not B, not equal to 1. So again, let's start. So we start with a C. So C is to be true. So it's this column here that we're interested in. Not A means all the ones in which A is false. So that's these first 2 rows. And then the third one is where B is false. B is false on this top row. So where does this top row intersect with this one? Over here. So now we try to group them. And in the process of grouping them, we are going to try to have a look at, let's have a look, let's group them. So let's group this pair. Let me use a different color, right? So those two are going to group like this. So what is constant between these 2 items? C is constant, but also when you look across to here, what's constant? They're both 0 here, A and B, but here B, not B. So actually, not B and C are the 2 constants, which give us those 2 values. Therefore, that is the simplified circuit. And you will find that that corresponds quite nicely to it. Now, the issue is that there's a bit of a gap between them. And the problem with that, you might ask, you might say, is that how am I grouping them when they're so far apart? Strictly, the order in which I wrote this could have been written in a slightly different order. This I could have placed up here, 1, 0, then place 1, 1, and 0, 1. Then you would have seen a different structure. The concept is the same, but the structure is slightly different. So we'll do this alternative version just now. Let's just rub out the sequence in which we've done this. Let's get rid of that. Let's get rid of all of that. Okay, keep those because those are the logic we need. Get rid of this. Right. Okay, so let's get our deleting thing and let's delete that column there. And let's delete that and do it again. Right. And show you a different way of constructing it. So I need 1, 2, 3, 4. There's A, B. There's C. Okay, so C can be 0 or 1. Start with 0, 0, but this time I'm going to put 1, 0, 1, 1, 0, 1. So our statement was A, not B, C, or not A, not B, C. So let's take the first one. So it's A, not B, C, turn it to 1. C has to be true, that's this column. A has to be true, that's this one or this one. They're both A true, but not B. So it has to be the 0, this one here. So we put a 1 in there. Let's look at the second bit. So it's not A, not B, C equal to 1. Again, C is true. Not A is true and not B. That's these two here. So it goes there. Now you can see in the way that I've constructed this one, it's easier to group. They're right next to each other. So it's worth bearing that in mind when you write out these columns down this side here. So what's constant in this grouping? C is constant, and over here, B is the constant, but it's not B. And there we go, we get the same result. So that's how you would use a KMap in this simple example.